interest for VeriPB going forward? Please.
Yeah, so as Jakob told you, I was asked to make some provocative statements during the closing talk, so this is a bit what I'm going to do. So I'm going to talk about my experience with SAT4J and VeriPB. So SAT4J has been designed in the time where there was no proof logging, so that was 21 years ago for the SAT part, 20 years ago for the PB part, and so mainly, even if there have been some work done 2015 or 2020, all the main basic stuff is really, really old. And there are two different engines. So actually, what we really want to do in 2005 was the cutting planes based solver, but at some point it was so deadly slow that we said, well, let's do the resolution just to see, and it would happen to be the one we use by default because it simply works. And so the thing is, I've been doing proof logging for SAT4J in different number of times. So we started in 2004 for SAT, but then we got only proof logging that really worked and that was really easy to implement in 2013 with the drug format. And actually, it took me 15 minutes to implement proof logging the drug. And actually, it was 15 minutes. Then Marijn complained because he couldn't check my proof, and he said, "Oh, I forgot to add the D line." So I added the D line, 1 minute more, and everything was fine. Then we worked with VeriPB1 because we heard about VeriPB. So there is VeriPB1, VeriPB2, maybe VeriPB3. So I mean, there are different flavors of VeriPB, but the VeriPB for NSAT, we use it in our lab with Anthony and Romain because it was nice to prove from academic problems and so on. That was nice, and it was not very difficult to implement. Last year we already heard with Florian of iDrop. So iDrop is incremental drop. So it's a bit more complicated to do because then you are not just working with one call to the SAT solver, but you have several calls, and you have to pay attention a bit of things. And actually, with Iris, who was doing a master thesis, she implemented the first testing in SAT4J, so we were able to make sure it works for any kind of solver you are in SAT4J. That was nice. And then I tried to say, well, okay, there is a PB competition, there will be VeriPB proof, so let's implement VeriPB 2.6. I said, okay. And then this is when I complained last year. It was not that whoops, but that sloppy. And so this is the talk, and then we decided to team up, and so I spent quite a fair amount of time with Mark and Veda to make sure it works in SAT4J, and this is all about the first part of this talk. So why is there a difference between the academic problems and the real problems you can get in the competition? Is, well, maybe if you take a look at the PB competition benchmarks, you can have unit close because users, they just have their constraints, and then at some point they put unit closes. And what you do in your SAT solver, you're going to simplify all the things. And when you do that, this is what is done. Even if you do any kind of SAT solving, you will just get rid of, simplify as much as possible all the clauses. And if you do rep, you are not going to see that. It doesn't matter. But if you do LRAT, or if you do VeriPB, you have problems with that. And so the thing is, I thought I was okay, and I submitted to just the warm-up of the PB competition, and the EO said to me, "No, Daniel, your certificate are wrong." I said, "Come on." And then I was fed up. I said, "Okay, I'm not submitting any certified version for the cutting." But the thing is, the resolution was just providing rep statement, and it was working with the very same benchmark. I say, come on. So I think I did a statement saying that the problem is all this propagation simplification that you have is done when you read the formula. Okay, and there is no event. So mainly You have this tracer stuff in Radical, so this is something I had also in that project. This is usually it's easy to have a proof, but there is no. I have no event in the simplification page because it's when I read the formula, so it's before the search. I only have events when I search. Maybe if I had to rebuild a new solver from the scratch, I would add event at that time, but this was not the case. So my claim last year was VeriPB2 was friendly to resolution system and unfriendly to cognitive placement. I thought my statement. And actually, this is not true, and I will show you why. But so, how can you change that? The problem is, this is a slide from last year. They said, well, the problem is I can create auto new event, but this will be a bit of a pain because there are 47,000 lines of code, and then you have to figure out where in the code you have to do that. And actually, there is no API fitting, so it would be tough. So would it be possible to have some kind of VeriPB that just doesn't care if I do some modifications to the original formula? Or could we have something easier than just to give all the information, and can we have derived it? So let me show you how we did it. So suppose Sat4j reads this constraint, and before it knows that x4 is equal to 0. So what will it do? Say x4 is 0, so you want to get rid of it. And here you want also to, because I like saturation. I'm not a division guy, so each time I can use saturation, I'm going to use saturation. I want to saturate on that one. And so what can I do? So what we find out is that we're going to use a very nice feature in VeriPB. We're going to use labels. Because what I need is, I read a constraint and I simplify it. So for VeriPB, this is no longer the original constraint. It's a simplified constraint. So what we're going to do, we have to use a trick when I read the MES constraint. I'm using this label that would say this will be the MS constraint, but modified. And I will have when I output my proof, if I know that I modified the constraints, I will use this label name instead of the original ID. And if I want to assign one literal, I will use also a label the literal. So here I say, all right, I know that this guy is satisfied. So this is not x4, so x4 is equal to 0. And I'm going to add it to the constraints, so it will get rid of it. And I will apply saturation. So now, what does Sat4j? When it reads the formula, it will output for each simplified formula a statement like this. And and also, if you look at, if you have 5x1 plus 2x2 plus x3 plus x4, you will see that you will have to propagate x1. But x1, it will only propagate that information if needed. So if later in the proof you have this constraint coming up, so here you would like to get rid of this element because you know that x1 will be true. So you are going to tell, well, I know by rep that this is satisfied. So please add it to the constraints with coefficient 3, because you have 3 here. And then you add x4, because so the x here. And we are going to weaken on this. And using this kind of things, we were able to mimic in the real proof what Sat4j was doing. So, nice thing about it. Those are the results of the SAT competition, the PB competition. So you do not really care about where it stands and so on, but what is important is you have unsat and SAT-C. You see for resolution this is the same, and you have upsat and 35 on the 35, you have the same numbers, right? So it means the proof have been accepted. Then you say, what's going on here? Okay, so this is just because I used the default solver here, and this is I have to have a specific configuration for the certificates. So it's not that adding proof login improves the solver. So this is the competition version. This is the default version. But mainly, again, all the proofs were accepted, so that was very nice. So huge improvement compared to last year. But now, what is the cost of that? So this is the number of lines of code last year on the main trunk. And this is what it costs. Changing 149 files, 3,000 lines of code. This is not a pure sprint statement. And so, well, okay. And this is only something that works on two different servers. So resolution PB24 and categorized PB24. So this, what I was trying to check the proof login for the presentation. I did the check and it didn't work. I said, what? And then because I forgot to change the name of the server to make sure that it works. So you really have to, it's not like, it's really, you need to, if you want proof login, you need to use any of those two servers. It won't work if you use other servers. So this is very specific effort. And the thing is, Jakob was always thinking, how many bugs did you find thanks to proof login? He didn't ask, how many bugs did you introduce thanks to proof login? Because at some point, for efficiency reason, we wanted to have sort of LRAT stuff. So to find out how your unit close, where your unit close are coming. And actually, it was just I had to change completely the invariant of the solvers, and that it just broke the solver, right?
Did proof logging catch the bugs that proof logging introduced?
Well, okay. So the problem is the following. So Vita showed you that one yesterday, saying, well, it's very nice with. So this is the CP solver, so it's very slow. It doesn't provide much stuff, so it's easy to check. But if you ask resolution, it provides a huge amount of and it is very difficult to check. And to be able to improve this, you need to provide all the hints. So we know that to improve this behavior, you need to provide it. But the way Sat4j is designed, because you do not keep the unit close, it's like Minisat, they are just on the trail. They do not exist really. Then it's just a pain when you call many solvers, many times the solver, because you are doing optimization. I mean, I had to break things, and so I haven't implemented hints for LRAT sort of to be able to change that. So it's not so easy to implement and to have something efficient if you do proof logging. But then one of the things about what we heard during yesterday and today is, okay, we have those rules on the VeriPB. We'll make sure you use those rules and correctly. That's fine. But what we know, so this is since Roman thesis, that sometimes you apply the rules and what you get is something that you would not like to get, and especially what we call irrelevant literals. So. And I'm wondering, now that we have VeriPB proof, so the VeriPB proof is really a statement of whatever the solver generates. Can we do, and can we detect that, and can we find a way to prevent that? So let me recall you what we call irrelevant literals. So we have two PB constraints here. We are going to sum up and to see what we get. And this is something that is really strange. So it's completely legal to do this. So we sum up. There shouldn't be any problem. So this one should cancel, right? So 3 plus 3 minus 3, which is 3. And we have 2a plus a is 3a, 3b, and c is only this one here. And if you look at this, you will see that when you do not, you will satisfy these constraints independently of C. Okay, because If you do not satisfy those two guys, there is no chance that you are going to get more than 3, or at least 3. And if you satisfy any of them, you will satisfy the constraint. So the value C is irrelevant in this constraint. So this is, so it means that you should be able to, there should be a way so that you can get shorter constraints because C is not relevant. And so you can tell, well, is it really a problem? Yeah, the thing is, we would like to be able to remove them. And it can be also, so this is some experiment done in SAT project, but it's the same in running SAT. So whatever benchmarks from the PV16 competition you could take, you will mainly generate some of them. So that was done by doing some kind of checking all the constraints that were generating during the resolution. And so it's very a problem that you can find, and we know that running SAT and SAT logic do that. And what is really even worse is when you start to have, so this is the previous constraint. If you take 2 constraints with irrelevant literals, then they can make the literals artificially relevant. And this is this case here, because now you sum them up, but T becomes relevant again, because then you can, with C, you can satisfy the constraints. And so this is really there's something really going on here, and that you would like to avoid because you could obtain just at the end, without these irrelevant literals, B plus D greater than 1, which would be much better. And actually, I know that this prevents the solver to just finish a proof because it doesn't learn the right constraint. So those irrelevant are really painful, but yeah, it's NPR to find if a literal is irrelevant or not. So it's a bit of a pain, but what I would dream is I just look at my VeriPB proof. He said, okay, you're correct, but not that you have in line 27 an irrelevant literal, and maybe you could do better.
Detecting irrelevant literals is simply hard for a single constraint or for a
for pseudo constraint, yes. It doesn't happen in clauses, or all literals are relevant in clauses. It only happen for constraints.
My question is, okay, so if I detect all irrelevant literals in each single constraint, and I remove them, then I don't get artificially relevant.
Yeah, sure.
Right. And my question is, for a single constraint, is it already NP hard?
Yes.
Yes.
It is.
Yes. Yes. So yeah, so I would dream of a VeriPB option. So because it's impaired, you are not going to do that all the way, but because now we have those proofs where we have those constraints, then we could have some warning sort of saying, maybe something wrong happens. Yes.
Is it strongly impaired or weakly impaired? Is there a pseudo-polynomial time algorithm to do?
Basically, detecting irrelevant literal is equivalent to solve a subset sum.
Yeah, so it's but so this is the yeah, something that would be nice. And I received an email yesterday, and I think we should just remember why we are doing proof logging, or we are certifying things. Right? This is what kind of things appears on archive. So it's 9th of September. So there is an evolution-based LLM that took KeySAP and I tried to improve it, and the author claimed that it's much better than the best version of KeySAP that has been made. So if the source code is not available, right? So for the moment, probably it's submitted somewhere. And so if LLM are going to write the next generation of SAT solver, for sure you want to approve, and you want to approve of SAT or NSAT or optimal, and so VeriPB is the nice format for that, because this is the main thing about VeriPB, that it's not only unsat, because this is what you get if you do wrap or wrap. Here with VeriPB, you have everything. And so this is the nice thing about the proof format. And then I wonder, so I just got the paper yesterday. I didn't go deeply into it and how they check that it's correct and so on. But yeah, this is maybe, I don't know. I think it has been discussed already in the actual a few days ago. But this is something a bit freaky about what's going on. When you like to know for sure that what you get is really sat or unsat. So thanks for your attention.
Questions for Daniel?
Yeah.
So the reason why you get irrelevant literals is because the solver is already having irrelevant literals in the
No.
or
No.
It's introduced by proof logging, or I'm not.
No. It's just yes. It's just that by applying completely legal resolution, you combine two PB constraints. You can. So the problem is there must be a way that tells you shouldn't combine So what we do when we combine two PB constraints, we need to make sure that the resulting constraint is conflicting. So we have to tune a bit and weaken the constraint to make sure it happens. So probably we need an extra verification to make sure that we prevent that. That would be nice, to have some kind of
Irrelevant literals can be introduced during conflict analysis.
Yes, but my question is if this is a problem because you're proof logging?
No, it's a general problem, but the fact that you have proof logging, now you have a general format where you know all the steps that any solver is doing. So you can check for irrelevant literals. And then you can check that
Also
it happens, and then how you can solve it. Because we know that it happens for SAT4J, it happens for running SAT. So if there are any other, so do MIP solvers produce irrelevant literals? I have no idea. But if we have a common proof format, and we can check that, so it's EV, but it's in PR. But
how I see it, this is not a matter of, in the sense that you're going to have the list of the classes you have, the Boolean constraints that you have introduced, right?
Yeah.
And then you can just do that check.
Yeah, no, but so what I mean is when Romain worked on this, you had to add the proof, you had to output for whatever the solver was doing in a format. And so now that we have commonly accepted VeriPB output proof logging, so we know we have that information for free for all the solvers that implement it, so we can do that check. It's easier.
Oh, you mean that it would be nice to have a tool within VeriPB?
Yeah, so taking VeriPB and finding the first place where there is irrelevant literals and so on. What we would like at the end is to be able to find a way to avoid this. Is there a way to, if you combine PB constraints, to ensure that you are not producing irrelevant literals? That's simple. Well,
so if you prove somehow that the literal is irrelevant, how do you put it into VeriPB? How do you justify to VeriPB that I have removed this literal?
No, I mean for the moment I have no idea.
But suppose that you solve the NP hard problem, right? And you say, yeah, this one is irrelevant. Can you do something VeriPB to prove? Like, do you have to write the entire refutation of the NP hard problem to say that this is irrelevant?
Because I mean, the fact that it's irrelevant, it means that you can just tell that you can derive. So the fact that it's irrelevant means that you can get rid of it. It doesn't matter whatever the constraint is. So you can derive something stronger.
But if you give to VeriPB 3A plus 3B greater or equal to 3, what
In
would it
this
say?
case, I think you could do it with a simple proof by contradiction. If I'm not
Okay.
like because if you assume that 3A plus 3B greater or equal to 3 is false, but this constraint before striking it out is true, then from this you will derive that well the contribution must have come from C then. But C can only contribute 1, and now we have contradiction. So I think this I'm doing this a little bit online, but in general, I mean, probably for these kind of things, you'd have to whatever algorithm you use to figure this out. I mean, you'd need to write this down in pseudo form, and that would be the proof.
But will it be sufficient to have the literal axioms of those irrelevant literals and add them to this constraint?
No, you want to go in the other direction, right? You want to remove this. You're claiming that you know that 3A plus 3B plus C is greater or equal to something.
Yeah,
Now you're saying the still inequality, the inequality holds if I remove the contribution of C. That is not obvious. That you can't do by a literal axiom.
So is this NP hard or co-NP hard?
If you do subset from
Well, it depends how you ask the question. Depends whether you ask the literal is relevant or irrelevant.
Presumably,
Yeah, it's called,
it's got a very short
it's
way of
relevant.
justifying.
The weakness is here's an assignment where it makes a difference.
Yeah.
So it's going to be hard. If it's relevant, it's going to be hard.
Yeah. Which sort of suggests you wouldn't have a short proof.
Actually, in practice, to detect this, we use the subset sum algorithm, so it's not really easy to output a proof.
Subset sum is dynamic programming,
Yes.
and we know how to do proofs for dynamic programming. So
But I think just to comment more widely on this, I think, yeah, so the very first introductory talk yesterday morning gave this promise of, just add print statements to your code. And I think I sort of said at the time that this is getting increasingly false, and maybe it's just a bit too good to be true. I mean, we're producing these Sat4j and the Glasgow subgraph solver. They're doing fairly nifty reasoning, and maybe we have to sweat a bit to produce the proofs.
all we're doing is that every place in the solver that does some kind of reasoning, we're putting in a few print statements. The difficulty you had, I think, is you don't know where you're doing reasoning because you're doing reasoning in the input-output parsing.
yeah, because those are simple simplification, and that you do not
It's
need for
reasoning.
any what is.
Yeah, but it's reasoning in a particular. I mean, for instance, constraint programming. How is proof logging constraint programming going to happen? It's probably someone has to sit down and write a super nice library or something. Like it's not like, of course, everybody should get the PhD in proof complexity. That's self-evident, but I'm not sure if all researchers in the world would be all people who are working in combinatorial optimization. Maybe they care more about combinatorial optimization than proof complexity. And I think we have to face it that writing proofs is hard, and it would be good to do something about it. But
I would say this is still useful. Also, in your case, where you do implicit reasoning during parsing, because in Cadical, before I did this work on LRAD, there was also like implicit reasoning during parsing of clauses, which is not an issue before you start using the solver incrementally, where it can be an issue when you suddenly are not consistent with unit clauses anymore. So this was actually probably buggy in some cases, and it was detected by introducing this implicit reasoning. So there's a trade-off, of course.
Yeah, yeah.
That for J is probably correct by
just a lot of testing and lots of users, but I mean, these sort of bugs, they are very sneaky and they can.
Yeah, I know. But the main issue is about adding labels for the root proofs is that we are in a case where you call several times the solver, it's incremental. And so I need all the ideas of those unit clauses. And I said, okay, I'm not going to, because I was breaking everything. And say, I'm not going to break. I don't have time to make sure everything is fine. Yeah. So I just stopped. So it's on the ground. If you want to take a look, you can. VeriPB too with labels.
So I think we should thank Daniel again and thank all speakers. The EuroProofNet network for allowing us to be here. Thank you so much.